The focus of this video is equivalent fractions and proportions. First, you need to understand this concept. Any value divided by itself equals 1, excluding 0. By excluding 0, I mean 0 divided by 0 is undefined. If you put that into your calculator, you would get an error message because you can't divide by 0. So it doesn't work for 0 divided by 0, but it works for all of the other numbers and variables. For example, 3 divided by 3 equals 1, 8 divided by 8 equals 1, 17 divided by 17 equals 1. I hope you're starting to get the idea. Let me skip over to the negatives. Negative 511 divided by negative 511 equals 1. So it also works for negative numbers. It also works for variables. Y divided by y equals 1. If the numerator and the denominator are the same and you're dividing, you're going to get 1. Now that you understand that, we can talk about building equivalent fractions or ratios. If you are going to build equivalent fractions by scaling up, you are multiplying. So let's start with the multiplication examples at the top here. So I need to grab a pen for this, and I'm going to create an equivalent fraction. So what I'm going to do is I'm going to multiply 3 by 5, and I get 15. I'm also going to multiply 4 by 5, and I will get 20. Now the reason why we talked so much about a number divided by itself equaling 1 is so that you can see that if you multiply a fraction by 1, if you multiply something by 1, you're not really changing it. You know, 3/4 multiplied by 1 is still 3/4. However, you're just changing how it looks. So 15 over 20 looks different than 3/4, but these are equivalent fractions. So this is a method for building an equivalent fraction. So 15/20 is equivalent to 3/4. Let's build again. Let's say I multiply 11 by 6. I'll get 66. Now, you must multiply both the numerator and denominator by the same number to get that equivalent fraction. So I'm going to multiply 7 by 6 as well, and I get 42. So 66 divided by 42 is equivalent to 11/7 because technically all I did is multiply 11/7 by 1. And if I multiply 11/7 by 1, it's still 11/7. It just looks different. We can also scale down. We can build equivalent fractions by scaling down, and we would divide to scale down. For example, we can divide 35 and 14 by 7. So if I take 35 and divide it by 7, I get 5. If I take 14 and divide it by 7, I get 2. 5/2 is equivalent to 35 over 14 because we could also think of it backwards. 5 times 7 gives you 35, and 2 times 7 gives you 14. Look over here at 100 over 25. I can divide both 100 and 25 by 25. 100 divided by 25 gives me 4, and 25 divided by 25 gives me 1, which actually reduces to 4. So this fraction, 4 over 1, is equivalent to 100 over 25. They just look different. Let me go on to the next slide. This brings us to talking about proportions. A proportion is an equation that states that two fractions are equal. Simplified, basically a proportion is when you have two equal fractions. So 3/4 is equal to 15 over 20. I call this a proportion because I have two equal fractions. This is also a proportion, but in this proportion, the x variable is missing. Let me grab a pen. But to figure out x, we can use that knowledge that we are working on when we talked about equivalent fractions. You look for a pattern. From 11 to 66, are we scaling up or are we scaling down? Well, 66 is larger than 11, so we're scaling up. So what do you multiply 11 by to get to 66? You multiply it by 6. So we would also multiply 7 by 6 so that we have an equivalent fraction. So that would mean that x would have to equal 42. So I want to show you that proportions are useful because they allow you to solve for a missing variable. Because you know that the fraction on the left has to be equal to the fraction on the right. So there has to be some sort of relationship between them since they are equivalent. So in this example, to solve for x, you would scale down. 25 divided by 25 equals 1. And then we would also have to divide 100 by 25 to solve for x. 100 divided by 25 equals 4. So we would know that x is equal to 4. In the next video, we will use this information to be able to solve some story problems.